Okay, the next question. It's the same situation, as it's the same object, but now we're told that you have a frictional force of 100 dynes in the direction opposite of the motion. Okay? So now we know one of the forces that contributes to this net force. It's 100 dynes in the direction opposite motion. Now the net force is 4,000 dynes in the direction of motion, and from this we see immediately that there exists at least another force besides friction, because friction itself is only 100 dynes opposite the direction of motion. That force is 4,000 dynes in the direction of motion. Okay? If there wasn't some other force acting, then that force would not be equal to the force that's acting. Okay? So, well, let's write that down. I'm going to use F sub other for the other force. I'm going to use F sub FRICT for friction and F net for the force. And notice that I have arrows over these, because now these forces are going to be regarded as vectors. Now they're only acting along one line, okay, because we have motion, it's in some direction, and it's in the same direction as the acceleration. We have friction, but it's acting in the direction opposite the motion, so it's still along the same line. So all these forces are acting along the same line, so we can deal with their vector nature by simply using positive and negative signs. Now we need to declare, when we do this, we need to declare our coordinate system. Where's the origin and what direction is it, or well, what's the direction of the coordinate system? So we're going to let the x-axis be in the direction of motion. So now we've specified the direction of our coordinate system. In this case, the net force is plus 4,000 dynes times the I vector. I'm going to use the I vector. We don't really need to use it because we could just use pluses and minuses, but we're all familiar with the vector notation. So I'm going to just say it's 4,000 dynes times the I vector. There's no j vector, no k vector. Everything's along a straight line, so it isn't completely necessary to use the I vector, but we're going to do it. Okay, so 4,000 dynes in the direction of the I vector. What about friction? Well, friction is in the direction opposite the motion. Now the direction of motion is the direction of the I vector, so the force of friction is in the direction of the negative of the I vector. So I could say 100 dynes times negative I, but we know that's going to be negative 100 dynes times I, and we know this is going to accomplish the necessary goal of ensuring that the frictional force is in the direction opposite the net force. Okay, well, this is still true because the net force is the sum of all the other forces. Okay, now I don't know how many other forces there might be, but I'm just using F other to represent all the other forces. Okay, so this F other might in turn be a bunch of different forces, but all I'm interested in finding right now is all the other, the force that totals all the other forces. That would be this one. Okay, maybe you can, if you want to, just think of this as there being just one other force, just the friction and some other force. That's all right too. In that case, then, how do we find the other force? Well, we subtract the frictional force from both sides. We find that the other force is the net force minus the frictional force. So that's 4,000 dynes times I minus the negative 100 dynes times I, which is going to give you 4,100 dynes times I. Now, when we did this problem in class, before any of this had been explained, a lot of people thought it would be 3,900. Okay, because you have 100 newtons accounted for, or 100 dynes, I'm sorry, 100 dynes accounted for out of a 4,000 newton dyne force. But if you thought that, you failed to take account of the directions. One vector, the net force being in this direction, the frictional force being in this direction. And if you think of it intuitively, you're going to need 4,100 dynes to get a 4,000 dyne force if you have 100 dyne force acting opposite that 4,000 dynes. And that's very obvious. But it's very easy to get confused. You want to write down the vector equation and make sure you have that right, and then you need to work with that, and then you need to reconcile that with your intuition. And I'm not saying don't use intuition, use all the intuition you want to. Figure out that you think it should be 3,900 dynes if you want, or 4,100 if you happen to reason it correctly, and then run this through, and if what you get doesn't agree with your intuitive solution, check yourself out. If there's something wrong here or there's something wrong there.